let's recap again. Unit circle. Let's draw a unit circle. I'm going to draw a unit circle here. So we got a unit circle. 1, 1, negative 1, negative 1. Yeah? Unit circle has a distance or radius of 1. Tangraphs. Remember, tan is the ratio of your opposite by your adjacent. So if you think about it, I'm just going to draw this line here. If I chose this coordinate, this is your line. It's got a height or hypotenuse of 1. This is your y value, and this is your x value. So when you say opposite, see this is the angle. Opposite over adjacent is actually rise over run. Rise over run is your gradient. Okay, so that's why when we say tan of theta, that equals to opposite over adjacent, which is the same thing as saying sine theta over cos theta, because the opposite is your sine theta. Or you can think of it as y over x. And y over x is like rise over run, which is the same thing as your gradient. Okay? This is the same thing as the gradient. So it's gradient of the line. And what's a gradient? Gradient is just saying what's the steepness of this line. So you can see this is a steepness of 0. So remember back in gradients, you had 4 types of gradients. You have a positive gradient, you have a negative gradient, you have a 0 gradient, and you have an undefined gradient. Okay? So you have 4 types of gradients, and that's all you're analyzing. You're starting at 0 degrees, and you're going, as soon as you move anti-clockwise, that's a positive gradient. That's a low positive gradient, and you keep getting larger and larger and larger and larger. These are steepness. Steepness is high, so that means the rise is really high and the run's really low. Okay, so you can have a rise of 100 over the run of 1. So that means your gradient's 100. But as you increase the gradient, it can go infinitely as large until you get rise, it could be infinite, and then run is 0. And we know the reason why it's called undefined is because you got rise, let's say it was 1000, run is 0. Because if run is 0, the problem is you can't do 1000 divided by 0. That's why at the vertical point, that is undefined. Now if you understand it that way, so it went from 0 degrees, started off 0 gradient, so 0, positive, 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 it gets larger and larger and larger and larger and larger until you get undefined. So when you're undefined, you're at 90 degrees. So here we go, we're going to write 90 degrees, 90 degree, oh, 90, oh my god, I lost it. How do I go back? Yeah. 90 degrees, I've got undefined. Then after the 90 degree point, let's look at my gradient. As soon as I hit into the second quadrant, this is a negative gradient. So it goes negative, and it's a really steep negative. Then it becomes negative, small, negative, small, negative, small, negative, small, negative, until you get to pi. See, once you get to pi, which is 180 degrees, so once you've made 180 degrees, your gradient is 0. Okay, so you're back to 0 again. And that's called a period. Because remember, a period is how long does it take before you come back to the same cycle. And it took, from here you started at 0, 0 gradient, and it took 180 degrees before you made your next point, which is the same 0 degrees, or 0 point. Okay, so that's why the difference between a tan, cosine, and sine and cosine had a period of 2 pi, right? So they had a period of 2 pi to make one cycle. Tan doesn't. Tan, on the other hand, has a period of pi. Because it only goes from 0, as you can see, it goes from 0. When do I touch 0 again? After 180 degrees. That's why, if you look at your formula, what's the difference between this and sine and cosine? It's not 2 pi anymore, it's pi divided by n. Okay, so it's exactly the same drill. Same drill, okay? So this is representing n is the number multiplying to t, that's a dilation. That's how much you stretch horizontally. If you put a 2 there, you're actually shrinking it by a factor of 2. So it's halving. That's why it's pi, whatever your one cycle is, divided by 2. That's what that n represents. So n times t tells you it's a horizontal dilation. Whereas a, see, unlike sine and cosine, you had a cap. You had a cap at +1, -1. So if you think about the unit circle, I'll go back to a unit circle here. I'll zoom out a bit so you can see both. Yeah. There we go. So both of them, when you're talking about x values, it was -1 to 1. So cos has a cap between -1 and 1. Sine values, sine graphs are the y values here, has a cap of -1 to 1. But if you're talking about gradient, on the other hand, gradient doesn't have a cap. See, gradient can just increase from 0, keeps getting positive, positive, until you get to infinitely large, which is undefined. So the graph of a tan does not have any caps at all. Doesn't have a top end, doesn't have a bottom end. Okay, so that means if you have an A value, what does that do? It actually still does the same thing. It stretches vertically, makes it thinner or wider. That's what the A does. Okay, but you don't have an amplitude anymore. Sine and cosine had an amplitude because it had a cap. It was either at -1 to 1 or -1 to 1 vertically. Does that make sense? No? Yes? All right, let's draw one cycle of the graph so you get a picture or an idea of what it looks like. Here we go. This is my axis. 0 degrees is here. If we look at, if I just labeled pi and 2, pi, 2 pi, okay, and we were to describe the situation, it started off 0, tangraphs. For a tangraph, so this is a tangraph. Tangraphs started at 0, then as I increase, it had a low gradient, but it's positive. So this is a positive, it's low, so it starts off low, and then it keeps increasing exponentially. It gets larger and larger and larger, and it becomes infinitely large when you reach 90 degrees, which is pi and 2. So at pi and 2, you get infinitely large, but remember at pi and 2, it's undefined. Because it's undefined, you have an asymptote. So it gets really, really large, but it never actually equals to pi and 2. That's why it's undefined. Then after that, after you reach the pi and 2, what happens? Well, as soon as you move into the second quadrant, it's negative gradient, but a very large one. It's very steep. See, this is a very low gradient. That's a very steep gradient. Okay, so because it's a very steep negative gradient, we're starting very steep negative value. It's a very steep negative, a very large negative value. So therefore, you're starting on the very bottom here. And as you go towards pi, which is 180 degrees, you can see the gradient's getting smaller and smaller. So I'm going smaller and smaller and smaller and smaller. See, the y value is getting smaller and smaller. It gets smaller and smaller up until you reach 0 again. And that's one cycle. You see that goes up and it comes back up. The thing is, graphically, we don't like drawing it like this. So that's why in your textbooks, when they draw a tan graph, they normally draw it the other way. They normally draw it from here. Okay, so they draw it like this, they continue it on, and that's the one graph. They don't like it disjointed, and they normally then just say, they draw this in your textbook. So this is what you see in your textbooks. So why does it look like this? Same thing. Go with your unit circle. Think about your unit circle. If this is 0, then this is, the next one is negative pi and 2. The next quarter is negative pi and 2. So right here, it's negative pi and 2. This is negative pi and 2. What happens when you go into this region? As soon as you go into the fourth quadrant, you can see it's a negative gradient, but a low negative gradient, which is what's showing here. It's a low negative gradient, low, 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 larger, 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 and larger, until you get infinitely large and negative pi and 2, which is what's shown here. Okay, so it's infinitely large. It never touches it. It's undefined at negative pi and 2. And this is one cycle. And that's how we draw a tan graph. Now the nice thing about a tan graph, you know how with sine and cosine I kept telling you to draw the quarter cycles? You don't have to worry about this. You already got your cycles. They already got it. It's between where your asymptotes are. Negative pi and 2, pi and 2. And so you just rely on these asymptotes. Get your vertical lines down and you just draw this. La, la, la. That's it. If you notice, the nice thing as well, there's only one x-axis intercept. Think about it. There's only one. It's not hard to find. So it's always one. Tan graphs are actually the easiest ones to sketch. Sine and cosine are the harder ones to do. These ones are easy. So your x-intercept's only one. And do you want to find the next one, just add a period. Because it takes, how long does it take to get to the next period? And a period of pi, so the next one should look like, oh, there I left it here. It would look like this. And that's 3 pi and 2. And then I could do it again. And that's a 2 pi. So you can see every x-intercept, it's 0 plus pi, that's a period. Plus another pi, that's another period. Plus another pi gives you 3 pi. And your asymptotes, it's adding every pi and 2. 3 pi and 2, 5 pi and 2, 7 pi and 2. It's easy to sketch. That's your typical y equals tan of x graph. Okay, so that's your typical graph. One cycle is from negative pi and 2 to pi and 2, and it's a period of pi. Okay, and that's what we were saying here. So what this table over here is saying, period is pi on n. A is just the stretch, the vertical stretch. So if you change A, it just makes it thinner. That's all it does. N tells you how many cycles you have from one to the other. So if you shrink the graph, you just make it thinner. That's it. Okay? So if you had 2, then within 0 to 2 pi, you're going to have 2 cycles going on. So this is 1 cycle, this is 2. Okay? Yep.
Where T and L is like period of pi.
Yep.
Draw like the first one you did.
Yeah, exactly. So if they restricted the domain from 0 to pi, then yes, you're right. You would only sketch this part of the graph because it says from 0 to pi.
But normally they don't have a thing, that's why they do like continual.
Yeah, yeah. For every graph, there's no domain yet. It's only when you're doing the sketches for us then we tell you to put a domain in. But normally, yeah, when you type tan of x, it will go infinitely negative and infinitely positive, like that. Okay? All right, now, for these two formulas for you to look at, the range was clear. It's obviously going all the way up to infinity and all the way down to negative infinity. So it makes sense why ranges are. Asymptotes. These two formulas, you can either memorize them. When I teach my year 12s, I tell them to memorize because they spit too late by that time to try to understand it. But you have time to understand why that formula is. If you think about it, 2 times k plus 1, why do they do that? Because think about the pattern. You have pi on 2, 3 pi on 2, 5 pi on 2, 7 pi on 2, 9 pi on 2, 11 pi on 2. What am I reading out? What's the pattern? 3, 5, 7 plus 2 pi, but the numbers specifically, 3, 5, 7, 9, 11 are your odd powers or odd numbers. Because they're odd, it's 1, 3, 5, 7. So that's what they're doing here. See, 2 times k, whatever k is, 2 times that will make an even number. Plus 1 makes it odd. So that's saying it's going to be an odd number, odd pi. It's always going to be odd pi over 2. See, it's either 1 pi on 2, 3 pi on 2, 5 pi on 2, 7 pi on 2. And that's what this first part is saying. 2 times k plus 1 just makes it odd times pi. Why do you have the 2n? Because remember, n is responsible for shrinking it. See, if I shrunk it, if I gave you y equals tan of 2x, so your period changes now. Your period for this one will be p equals to pi divided by n. My n is 2. So that means to make one cycle, it is now pi on 2. So how does that change things? It just means if I would have sketched this graph, one cycle, it just means to go from one end, so from this asymptote to the next asymptote, that distance is pi on 2. If that's distance of pi on 2, then halve it. Halve it, that tells me this is pi on 4, and this is pi on 4. So a quarter plus a quarter makes a half. 1 quarter here, 1 quarter there. Okay, and so why is the formula 2 times n? Because if you have 2 here, remember you're shrinking it, and you're shrinking it by a factor of half. So if I actually said times this by a factor of half because n is 2, you can see 2 times 2 will make it a quarter, which is what I have here. Okay, so that's why they changed this to n, because whatever n is, it's a dilation from your y-axis. Yes, Jamal?
It says t-axis in this, not just x-axis.
Which one? This one? Yes, this is your, yes, yeah. I don't know why they called it t-axis actually. It must be because of their own graphs, the way they drew it. But yeah, this is really just finding your x-intercepts. So when you're finding your x-intercepts, it's k pi on n. Now why is that? It's the same thing. If you know the period is 0, pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, it's every pi. So that's why they wrote every pi, k pi. 0, 1, 2, 3, 4, 5, whatever the pi is. Divided by n, why is it n? Because you're shrinking it. Every time, if I shrunk it by 2, it becomes pi on 2. Okay, if it was 2x over here, then my intercepts now is every pi on 2. That's where my period is. So that's why my graph, if this is 0, to get to the next x-intercept, it would be pi and 2. Because that's a distance. From here to here is a distance of pi and 2. It's a period. That's what we said. That's why it's easy to figure out. It's just 0 plus pi and 2 plus another pi and 2 is pi. So for this graph, I already know what it looks like. It looks like this. Like that, that's pi. The next one is pi, then you draw that. And you follow on again. So the next one is 3 pi and 2. And you do it again. So the only part now is you just need your asymptotes. Now if it's a quarter, it's every quarter. You add on every pi and 2. So pi and 2 plus another pi and 2. So pi and 4 plus another pi and 2 plus another pi and 2 plus another pi and 2. And you get all your asymptotes. So pi and 4 plus pi and 2, which is like 3 pi on 4, and then 3 pi and 4, 5 pi and 4, 7 pi and 4. Okay, so I got all my asymptotes, and I've suddenly sketched y equals tan of it 2x. It's a really easy graph to do. So what I'm saying is you can either try to memorize these, they'll tell you all the x-intercepts, and they'll tell you the asymptotes. And all you need are the asymptotes, and you can just sketch them. Yes?
Oh, we do both equations in instead.
These ones? I can put them in. I can put them in just to work with you. By year 12, you need to know them, so you can memorize them. But I like to explain it so that if you ever forget, you can read the transformations and figure out the formulas yourself. Okay? But that also then means that everything I taught you beforehand, how to transform a graph. So y equals to, they currently wrote a tan of nx. What they're missing, well, I normally do bx plus c. bx plus c plus d. They're all the same thing. So this just means up by a certain amount, left, right, dilation, shrinks it, and dilation again. So if you think about it, that's just making it thin or wide, still the same thing. If it's negative, it reflects in the x-axis, so reflect in the x-axis. This one is up, down, exactly the same way I've been teaching, left or right. And then finally B tells you it shrinks it or it like widens it. So this would now be factor of 1 on B. Okay, so if it's 2, then you factor by half. If it's 3, then you're squishing it by a third. Okay, and if it's a half, then it becomes a factor of 2. Okay, and then yeah, so that's how you read your graphs. And now if you go all the way to your questions, it's really easy now. Let's have a go with some questions. Okay, so just so you get a good feel of this. Let's try this. It says here, sketch the graph of the following negative pi to pi. Yeah, and I've got 3 tan of 2x. Let's work out my period first. What's my period in this case? 3 tan of 2x. Pi on 2. Because remember, the period is normally pi, but then whatever the value of n is, which is 2, that shrinks it. Now it shrinks it by half. So normally it's pi times a factor of half. That gives you pi on 2. Or you can use the formula and just go pi on n. Okay? So I now know the period is pi on 2. And I also know that it doesn't move left, doesn't move right, doesn't move up, doesn't move down. The only thing that I have here is stretches. It makes it thinner. So if I draw the graph from negative pi to pi, so let's say negative pi is here, and pi is here. I start off by working out, well, apparently one cycle, the period is pi on 2. So that means this asymptote to the second asymptote has to be a distance of pi on 2. So if this is from here to here is pi on 2, then halfway has to be pi on 4. Okay, because you think about it, it's pi on 2, you halve it, that means from here to here has to be negative pi on 4. This has to be pi on 4. Okay, I'm just using logic now to sort of sketch it. So if that's pi on 4, to get to the next one, you have to add pi on 2 again to find the next cycle. If you don't like this method, then you can just use this formula. So you can use this formula here, 2k plus 1, 2k plus 1 times pi over 2n. That will tell all your asymptotes. So how do you figure it out? If I want to figure out my first asymptote to the right, that's when k equals 0. So if k equals 0, you got asymptote at pi on 2 times n, and now my n is 2, so it's pi and 4. See what I'm doing? So n, which is 2, if k was 0, 0 times 2 is 0, 1 times pi is pi, 2 times 2, pi and 4, which is true. That's my first asymptote. If you want to find the second one, it's when k equals 1. So if k equals 1, you have now a is equal to 2 times 1, which is 2, plus 1 is 3, 3 pi on 2 times 2 is 4. So 3 pi and 4. So that works too. You can do it that way, or you can use logic. And you can say, well, if that's pi and 4, to the next one, the period was pi and 2, well then to the next one, just add by pi and 2. So if you add by pi and 2, that gives you 3 pi and 4. Okay? And you draw. Once you draw the asymptotes, it's really easy. You just follow it in, you just carry it on, you just go, yeah, there we go. You want to find your x-axis intercepts. That's at 0, because you haven't moved left or right. You want to find it to the next point is a distance of pi and 2. So this has to obviously be pi and 2. You want to find the next one, add another pi and 2. So the next intercept has to be here. So logically, I just did 0 to pi. But you can do the same thing if you find all the x-intercepts. This is 0, the next one is negative pi on 2, and the next one's negative pi, and you've got negative 3 pi on 4, and you can do it again. So it just goes like that, and then like that. That is my graph from negative pi to pi. That's why tangraphs is one of the easiest ones to do. But when you first interact with it, it feels hard. Yeah, because it looks hard, it's tan, we don't know what it means, but if you really think about it, it's one of the easiest ones to do. That's why there's only like, how many questions are there? There's only 4 questions for tan. Okay?